Okay, here we have a system of equations, and we're asked to solve for x and y. And we have a choice of substitution method or elimination method. Well, because of the fact that there are a 3 and a 6 in front of the x's, and a 5 and a 2 in front of the y's, the substitution method would not be the best choice. You would normally use that when one of these variables has a coefficient of 1 or has already been isolated. So instead we'll use the elimination method, also known as the addition method, and instead try to figure out if we can find a common multiple between either the x coefficients, so a common multiple of 3 and 6, or the y coefficients, a common multiple of 5 and 2. Well, obviously 3 and 6 work very nicely together because 6 is already a multiple of 3. So the elimination method has this idea that you will multiply one of the equations, or both, in this case the first one, by some number, both sides of the equals, keeps it balanced, so that you will end up with the same coefficient in the x spot as you have here, but with the opposite sign. So what could you multiply the first equation by so that this 3 would become the same number as this 6, except for with the opposite sign? Well, clearly, we would need to multiply the first equation by -2. Now let's see why this works. So I'm going to document it like this. -2 times equation 1. What does that give you? And you multiply it through. It's like the distributive property on both sides to all terms. So you would get -6x plus 10y equals, and then timesing -2 by -3 is 6. Now if we just recopy equation 2 from above, we would have 6x plus 2y equals 5. Now the reason that this is a good thing is because there is a property that says if you have a system of equations, it is a legal move to add the equations together vertically. So if you've got all your columns lined up nice and good, you can add, and what will happen when you add a -6x and a positive 6x? Well, as you know, that's going to be 0. And so that's why it's called the elimination method, because it eliminates the variable x, and then when you add the y's, you get 12y equals 11. And then to solve for y, all you have to do is divide both sides by 12, which gives you y equals, that fraction's already reduced, 11 over 12. Now in some cases you would say, okay, now that I know that y equals 11 over 12, I'm just going to substitute it into one of the original equations and figure out x. However, if your answer is a weird fraction like this that can't reduce, I'm going to show you a trick that will prevent you from having to work with fractions to solve for x at all. Assuming you're doing this by hand, this trick is going to be way easier. The trick says, now that you've got y, instead of substituting it in to get x, the trick will be go back to the original system, and instead of eliminating x this time, what if we focused on the y coefficients and just went back to the start and said eliminate y? Or I'm going to turn the page. So here's the system rewritten, and all we have to do is figure out how to eliminate y. So what's the lowest common multiple of 5 and 2? Well, it's 10. They already have opposite signs, so really we just have to multiply both these equations up to get 10s in the y spots. So we're going to multiply the first equation, equation 1, by 2. Note how I document this. It's a great strategy for looking back at your work later on. So 2 times equation 1 gives me 6x minus 10y equals -6. Remember, we're trying to get a 10 in the y spot for equation 2. So if we multiply it by 5, 5 times equation 2, we'll get 30x plus 10y equals 25. So then when you use the property of addition, in this case, a negative 10y and a positive 10y in the y column will cancel. And so you get 36x equals 19. And so then dividing both sides by 36, you get x equals 19 over 36, which is fully reduced. Note that in all of the process, I really wasn't working with fractions, even though my final answer was a fraction. And when I go to fully report the answer, I want to give it as an xy ordered pair. I know now that x is 19 over 36, and from our previous work, we know that y is equal to 11 over 12. And so even though that seems like a pretty complex, crazy solution, it's simple to get to if you just remember this trick of using the elimination method twice separately in a row. Hope that helps you, and have a great day.